Hi class, this is Professor Teixeira. In this video, I'm gonna show you how to construct a proportion chart. We're also known as P chart. We have here an example. A production manager at a tire manufacturing plant has inspected the number of defective tires in 20 random samples. Each random sample has 20 observations. So each sample has 20 tires, okay? This also comes from the textbook I'm going to show you. Here's some computation, but I'm going to show you how to do that in Excel. So let's take a look at the textbook. So here's the textbook, the same example, and here is the data. For each observation, for each sample that the inspector selects, it selects 20 tires and inspect the number of defectives. Okay, so in this first sample, the manager goes there, the quality control manager goes there, gets 20 tires, inspect, find 3 defectives. Then waits, gets another sample, then another 20 tires, and then inspects, so that's the number of defective. Okay, I got this data and put here with the information that we're going to use. Okay, so here the samples 20, number of defectives. So what is the sample size? So the sample size is 20 tires. Okay, so in each sample there are 20 tires. What's the number of samples? Here we know there is a 20, but we also could use a function in Excel to count. We could use the function count A, which counts the number of cells in a range that have information. So if select this range of cells, it should return 20 cells with information. So I know that I have 20 samples. Okay. All right. So far, so good. Now the fraction defective, how we compute that. That's not difficult. We can get the number of tires in the first sample divided by the number of tires in the sample. So the sample has a size of 20 tires. So how many of them are defective in 20? We get the number of defective divided by 20 and we get the fraction. Let me do this. We can do this for the second one. We have 2 defective tires divided by 20 tires in the sample. I could keep doing that, but it's not too effective. So what I want to do is I want to copy this formula down, but when I copy, I have this issue because as I copy, the cells go down, but also go down here. But then we don't have information. So what we have to do, I'm gonna show you how to do it, is I want to lock this 20 here because I want to scroll down with this function, go down with these numbers, but keep this locked. So I come here, I check, that's what I want. So what I do is I go in front of the letter C and I type the dollar sign, and I go in front of the number 4 and type the dollar sign. This is locking the cell C4, okay? Now I can copy, and now if I go to the last one just to check, I go to the formula function tab. Yes, it's dividing 1 by the sample size 20. I have the correct defectives. Okay. Now, all right, we got the defectives in each sample, the fraction. Now, how we compute the p-bar? Let's go back to our slides. And here what we need is a p-bar. You see? P-bar. The p-bar is the total number of defective tires divided by the total number of observations in all samples. How we do that? We come here. So that's the reason I have a cell here called sum of defectives. What I do is I'm gonna sum all these defectives here, all these tires that are defectives. So how I do that? I type equal sum, open parentheses, and I select the entire range of defective tires, close parentheses. So it's 40. Oops, it's supposed to be in the sum of defectives. Let me do it again. So I go to the sum of defectives equals sum, open parentheses, select the number of tires that are defective. So I have 40 defective tires like we have here. Okay, 40 defective tires. I'm gonna reduce these decimals here. And how many tires in total we have in all samples? Each sample has 20. I could type each sample has 20 times 20 samples, right? That's 400 tires. I could also come here and say, I have in each sample, I have 20 tires times the number of samples, which is the same as 400. So let me go ahead and centralize all these cells. Did I do? I like everything. Okay, yes, I did. All right, which I got the same here, 40 and 400. What is my proportion? My proportion is equal to the number of defectives divided by all tires in all samples. That's the proportion of defective tires in all tires that are sampled, which is 0.1, okay? And what is that's my proportion. But now I need the standard deviation of the sample proportion. This is what I need. I need a standard deviation of proportion. So I'm going to implement this formula into Excel. So, okay, is a square root of this proportion of 10 times 1 minus 0.10 divided by the size of each sample, which is 20. So let's do that in Excel. This is called sigma, which is the standard deviation of proportion. So it's going to be equal to, I'm going to type equal SQRT, open parentheses, and then now comes the numerator. So I'm going to do the top part of this ratio, okay? To do that, I'm going to enter another parenthesis, okay? So here I have 0.1, that's the proportion, 0.1 times times, I'm going to type times 1 minus 0.1, close parenthesis. So that's what I did. I implemented this top portion, okay? Now I close parentheses, I can divide by the size of each sample. That's 20, I can type 20, or I can come here and that's my size of each sample. I close parentheses, that's the parentheses for the whole function. Maybe, let me see one more, I don't know, yeah. Let's see if it's gonna do the job. Maybe I entered too many parentheses here, yeah. So let's see what I 0.007. So let me see what I did wrong here. Oh, is here. I should enter this. Now I got it. You see, sometimes we are typing too many formula that is more complex. I should have put 1 minus C32 within parentheses. I did, and it solved the problem, okay? All right, we have the standard deviation of proportion. Now let's go back and see how the formula is. The upper control limit is the proportion, 0.10, plus the number of standard deviations we want, represented by this z. We want 3 standard deviations times the standard deviation of proportion. So it's 0.10 plus 3 standard deviations times what each standard deviation is. Let's do it. Okay, so my z is 3, and now my center line is simply my p bar, and now my upper control limit. Let's start with the upper control limit, like I showed you. So my upper control limit is the proportion plus the number of deviations I want times what each standard deviation is. I got 0.301, 0.301 like here. For the lower control limit, what we have is the same thing, proportion minus, this one is a mistake, is minus the number of deviations times the standard deviation, like in here. However, If the resulting number is negative, like here, we have to replace by 0 because there is no negative proportion. So if the resulting number for the lower control limit is negative, then we enter 0. Let's implement that in a formula here. The formula to implement that is equal max, okay? Max open parentheses, and then we're going to enter the proportion minus 3 deviations times the standard deviation, okay? Comma. I enter all this formula and I type comma. If what I'm telling Excel is, by doing this, if this is negative, I want you, then I'm gonna type 0 and close parentheses. So what this function is doing is, I want Excel to return the highest number of this formula and 0. If this formula is negative, the highest number is 0, Excel is going to return 0. If this number is above 0, then it's going to return it. Because the number is negative, it returns 0, like here. The number is negative, then Excel returns 0. Okay, so that's how I build the upper lower control limit. There are some steps here to follow. Now let's fill out these cells and come up with the chart. My lower control limit is 0, so I can type here 0 and 0 for all them. And my upper control limit is 0.301. I can double click like that. And now I can select the entire data set, go to the Insert tab, recommended charts, go to this quality control chart. There we go. We can replace this by P chart, my P chart, and then replace whatever you want. And again, we have an upper control limit, which is 0.3, a lower control limit, which is 0. Proportions cannot be negative. And we see that sometimes we have a lower proportion of defective, sometimes higher, which is a common variability for any process. Sometimes higher, sometimes lower. What we have to investigate, quality control managers have to investigate if this proportion goes beyond what is acceptable as variability. Above 3 standard deviations would be too much. Then it calls for a stop in the process and investigation why that is happening. So that's how you build a quality control P chart. Okay. Yeah, that's